All right, some of you wanted to see how we got the answers to our last two Schoology quizzes where you watched a video and then you had to answer questions. So let's take a look. In this one it says 0.5 times 4 to the x. So when you see x as an exponent, you know that it's either growth or decay. A, b to the x. The b is going to determine if it's growth or decay, if the number is bigger than 1 or smaller than 1. So because it's a 4, we know that one was growth. This question is using the formula a b to the x, but instead of b, they're using 1, and appreciate means to add r x amount of times. So you start with 15,000, and to appreciate means to go up by 1. So I see the answer for the power of 3. Number 3 in the middle. Oh, there's a typo of the video around 3.15. I got one answer wrong. I said, oh yeah, that was in the video. That wasn't correct. I remember that. I made that mistake. Let's see. It was decaying, so it's definitely a minus sign. And then it was 1 minus an interest rate. So remember, if they give you a rate, always make sure you make it a decimal by dividing by 100. And then, yeah, I had forgotten the 16th power on the video. Okay, here, this kind of was just going back to what are you doing every time, so you could write a model of it. Looks like you're multiplying, so every time you multiply by the same amount, it is geometric, and geometric is exponential, in this case, growth. This one, it looks like you're dividing by 2, which means multiplying by a half. So that would also be exponential, but it is decaying. It's not growing. It's getting smaller. So whether you multiply by a whole number or a fraction, it is exponential rather than linear. You just have to see if it's growing or decaying. All right, this one, a b to the x, looks like it's the model here. And again, this number now is a 0.5. So that's the number. So that looks like you had to subtract or you had to add, right? From 100. So it looks like you had to subtract for that one. So that one would have been decay. The 99 grams, decaying by 32 point, which means 0.234 for 5 minutes. Looks like it would be B in my situation there. Number 8. Doubling. So doubling looks like answer C. A, b to the x, and your b is a doubling phenomena. And your initial was your 15,000, it looks like. Tripling. So that should have been C, I do believe. And this one looks like you added the same amount every time. So when you add, you're arithmetic, and that would be linear. And while I'm here, I might as well just finish up the asymptote questions. We know an asymptote for 5 to the x is the x-axis itself, and this is the growth model. So in this question, it says plus 2. So a plus 2 on the outside does shift it up 2. So if you were to shift it up 2, a horizontal line is a y equals number. A log graph we just started looking at. So log graphs are the inverse of 2 to the x. So let's say 2 to the x, you already knew, looked like that. So the log graph is its inverse, where everything switches. I mean, I would love you to be able to say the log graph, well, the log of 1 is 0, the log of 2 is 1, the log of 4 is 2, and the log of 8 is 3. And graph those dots, 1, 0, 2, 1, 4, 2. You know, if you can do that. Otherwise, take 2 to the x and reflect it over the graph y equals x, because they are reflections of each other. So in number 3, the minus 5 shifts the graph down. So you should have shifted the asymptote down. In number 4, your inverse is when you switch them. So I really only see one situation where you switched them. 6 to the x, now you have x equals 6 to the y. And this is how you would write that y equals log base 6 of x. And finally, the hardest one here was if you took 3 to the x, 3 to the x would have already started at 0, 1. So when you move down 7, you're not down here at 7, you're really only at -6. The asymptote would move down to 7, but the point would be at -6. All right, so there's a nice quick